All right, folks. Well, last time we spoke, we left off with rotifers that have specialized organ systems and a special organization to their bodies. So now we're going to get into the most complex invertebrates and the largest invertebrates of class Mollusca. The mollusks, which includes snails, clams, squid, and octopus, they have a soft body. Notice that definition there. Usually protected by a hard shell, but as you'll learn pretty soon with your squid, that is reduced and used for other purposes. So take a note: snails, slugs, clams, squids, octopi, mussels, bivalves is one of the classes here. So these names are weird. You have gastropods or foot stomachs, bivalves, which are two valves basically, and the cephalopods, the head foots. And you have your examples up above. They are protostomes in their development, whereas deuterostomes, they're protostomes. They learn the recipe of making a calcium carbonate shell. Most have open circulatory systems, but your squid will have a closed. This weird image is a closed versus open circulatory system, where one is just out in the open, like an open pump in a bucket, whereas one is enclosed with specialized tubes so that you can pressurize it, and it helps to have a big body that you can move fluid around under a pressurized system. That's really the only way to grow big, is to have a closed circulatory system. So note that image. Here's a more complex definition of each of the major groups that we're not going to go into these definitions, but the groups you absolutely need to know of the gastropods, cephalopods, and bivalves. Kind of a go-between are the chitons. They represent not so much a missing link, but an example of a missing link, where they have repeating units like the segmented worms, but they have soft body anatomy like the mollusks. And so that's why they're mentioned here as like a go-between and in between of how these two groups are related. So first, let's deal with the gastropods, or the foot stomachs. You know these commonly as slugs and snails. Um, so we're obviously not going to dissect one of those, but you know what these things are. Slugs don't have a calcium carbonate shell. Snails do. The shells can grow clockwise or counterclockwise, much like our right and left-handedness. And depending on which way the shell grows determines whether or not one snail can mate with another. So that's kind of a weird factoid. Up next, notice this anatomy. You're going to want to know this. I will post this on Jupyter for you to study from, and there'll be a blank version that I'll make a pod quiz out of. Notice that the shell is derived from the mantle. Snails don't move into a shell. They grow their own shell out of calcium carbonate. We'll use that recipe to make hard tissue inside of our bodies. Notice they have gills, not lungs, and so that's a common theme that we'll see again with arthropods. The bivalves are weird. They start off as bilateral creatures, but then as they grow into adulthood, they completely change their anatomy to something that is absolutely not recognizable. I don't know if you want to call that asymmetry. It's certainly not radial, and they lose their bilateral symmetry completely. So we are not going to really memorize that anatomy. We don't need to really make much sense of that because it changes so dramatically into adulthood for these guys. So I'm going to post a separate video of a squid dissection, but the one that we really want to focus on, the one that makes us pause, is class Cephalopoda, the head foots. They're called head foots because their head is right next to their muscular foot. They are carnivorous, and one of the cool things they do for us in terms of thresholds is that they cross a threshold from open to closed circulatory systems, and they have complex nervous systems. An octopus and or a cuttlefish are incredibly intelligent and can problem solve. After the mollusks come the annelids. You have, the night crawlers that you probably fish with, the freshwater versions, or they live in the soil. There's also a marine annelid, this bristleworm. They have repeating units, and they are true coelomates, and so we use that. We're a coelomate, and we use the concept of repeating unit if you think about our ribs and vertebra, and then we adapted that or altered that for our purposes. So the annelids are segmented or repeating unit worms. They live in moist, wet environments. They breathe through their skin, basically. They possess a closed circulatory system. They have ganglia. Some of them even have retinas and eyelids. The three here are earthworms, bristle or marine worms, and the leeches. The weird thing about a leech, it can grow up to 5 times or eat up to 5 times its own body weight. So if that was one of you and you weigh 120 pounds, what would that make you? 5, 6, 700 some odd pounds after eating, and you would eat once a month. It's quite disgusting. Here's earthworm anatomy, where you can see that they have the repeating units of their circulatory, nervous, and muscular systems throughout their body, but they do have a front and a back end. So they move to eat and eat to move. And I'll post a video to show you how earthworms actually move with their bodies. Here is a more complex definition of each of those major groups. So you could read that once or twice. It's kind of a flash of AP level knowledge. But the cool things about the annelids is that they have two sets of muscles, and we have taken that to the nth degree with multiple layers and sets of muscles, especially around our core. Imagine them as just one small, long core of ab muscles. They will squeeze certain ones along the segment to constrict their body and then relax it. And they have longitudinal muscles that pull that body and push through the dirt. And so I'll show you a video of how they move with a giant earthworm from Australia. The last ones that we want to note here are the roundworms. They only have longitudinal muscles. They are pseudocoelomates. They're nematodes. They live in the dirt. They live in the creek. We've seen them under the microscope. And so they're usually parasitic, if not to you, to other things. They have a tough cuticle. A cuticle is like what's on the soft part of your fingernail. They have that around their entire body. They are the most numerous of all of these, the nematodes are. They can be found in most habitats. They're free living. Some of them are symbiotes. And they usually don't pose too much of a threat to us unless they're pinworms or hookworms. They live in the dirt. If you play in a sandbox or dirt, not you maybe, but a little sibling, you want to make sure you wash your hands after doing that. And then the last one here are the roundworms that cause trichinosis. And so if you like pork and or if you hunt wild game, you'll want to make sure that you cook that thoroughly, because they are parasitic for muscle tissue and cause muscle and nerve damage in large creatures such as ourselves. So there's a quick 7-minute video on these guys, and then we'll have a longer one on the arthropods, which are the most diverse and most numerous. Talk to y'all later, gang.